In this video, I will talk about the projectile motion. Suppose that we have a x, o, y plane like this, and then throw a ball with initial velocity v0, making an angle alpha with the horizontal axis like this. We neglect the air resistance, and we consider the acceleration of the ball in this scenario is constant, and that is the gravitational acceleration. Related to the projectile motion, we focus on 4 problems. The first one, velocity vector of the ball at any moment. Then position vector and trajectory of the ball. The next one is the height, the maximum height, and then the horizontal range, and finally the flight time. So we move to the next slide to calculate it. Because the acceleration is a constant, so we can write the formula for velocity and position vector like this. Take a look on this picture. We see that we have an x component and y component. Therefore, we can write vx component and vy component like this. If we write vx component, so here we write v0x, and here ax. If we write y component, so here we write v0y and ay. Do the same for the position vector. So we have an x component like this and y component like this. Now we will calculate the ax, ay, and v0x, v0y. We can see that because the acceleration of the ball in this scenario is the gravitational acceleration. Therefore, the acceleration along the OX axis is 0. We just have the acceleration along the OY axis. Because we pick up the positive direction is up and gravitational acceleration is down. Therefore, AY equal minus chi, where chi is gravitational acceleration. And we define v0x and v0y based on the angle alpha and initial velocity v0, where v0x equal v0 cosine of alpha, v0y equal v0 sine of alpha. Now we have the component ax, ay, v0x, v0y. We will put it in these formulas to have a velocity vector, position vector, and after that we will calculate the trajectory. So we put ax, v0x to the vx component, so we have this formula. We put ay and v0y to vy component, so we have this formula. We do the same for the x and y components, so we have the position vector and the components like this. So here I answer for the first question, velocity vector and position vector. Now we consider the trajectory. So what is trajectory in this case? It means that we write a function y depends on x. Take a look here. We have a x depends on time, y depends on time. So from here we can neglect the time to have a y depends on x like this. We consider the initial position v0 equals 0 and y0 equals 0. So we derive the position vector like this. From x we get the time out and we put it in the y like this, where t here and t here, you write x over v0 cosine of alpha. So you have a y, you actually neglect the time, and you have a function y depends on x. So we can see that here x square here, that means the trajectory is a parabola and it depends on the angle, so we have a different behavior of the parabola. So at this moment I show you the trajectory position vector and velocity of projectile motion. Now we should calculate the maximum height, horizontal range, and the flight time. So here I rewrite the position vector, velocity vector, and the trajectory based on three expressions. I will calculate the height and the horizontal range as well as the flight time. Firstly, let's calculate the maximum height. So take a look on this one. At the maximum height, the ball doesn't move up anymore. Therefore, the velocity along the y-axis equals 0. Based on this information, here Vy I write 0. From this equation, I can calculate the time like this. So if from given, I have initial velocity and the angle, so I can immediately calculate the time to reach to the maximum height. And now I will calculate the height based on the information of the y component. Take a look on the y component, I have information of the time. Now I will put the time where the ball reaches the maximum height here. So I have the formula for the maximum height like this. And the time to reach to the maximum height like this. So the next step, I will calculate the range. So we focus on the trajectory. Here at the final position, the y component equals 0. So here I will write 0. So then I solve this equation like this. So this equation have two solutions for x. The first one, x equals 0. The second one, x equal this formula. So this one is horizontal range, and x equals 0, it is the initial position. So we don't focus on it, we just focus on the horizontal range. So here is the range. And the time to the flight time in this case is double the time to reach to the maximum height, because this one, the time to reach to the maximum height equal the time from the maximum height to the final position. So here the conclusion for the maximum height and the time to reach to the maximum height, the horizontal range, and the flight time.